Video is Chapter 1, Section 2 of my PhD thesis entitled How Starships Protect and Enhance Civilization from Rescuing Refugees to Colonizing the Moon and Exploring Mars. So Chapter 1, Systems Engineering, Section 2, Resources. Starship uses liquid methane for fuel and liquid oxygen as its oxidizer. Starship also requires helium and nitrogen for its test flight program. Starship's frame is constructed of stainless steel. SpaceX has programs to acquire the resources that starships use to operate. Starship uses the Sabatier process to transform atmospheric carbon dioxide into methane, and the boring process to create oxygen from ice on and below the lunar surface. Starship's fuel is methane. Thus far, no methane-powered rocket has made it into orbit. In fact, Starhopper was the first methane-powered rocket to take flight. Starship uses methane because it prevents the buildup of deposits in the engine by coking. Furthermore, methane's higher performance makes it the most cost-effective propellant. With a liquid methane rocket, fuel is less than 1% of operating costs. In airlines, fuel is nearly 30% of total operating costs. In order to acquire methane, SpaceX is developing a program to pull carbon dioxide from the atmosphere and turn it into methane. Starship uses the Sabatier process to produce methane and water from a reaction of hydrogen and carbon dioxide. The Sabatier process takes place at elevated temperatures and pressures. Liquid oxygen serves as Starship's oxidizer, making it a necessary resource for ignition to take place. Starship's liquid oxygen to methane ratio is 78 to 22. Liquid oxygen is a very common oxidizer that was used in the first liquid rocket invented in 1926 by Robert Goddard, in the ascent stages of the Apollo-Saturn rockets, and in the Space Shuttle's main engines. Liquid oxygen is widely available and even less expensive than methane. Liquid oxygen is a powerful oxidizing agent. Organic materials burn rapidly and energetically in the presence of oxygen. Furthermore, liquid oxygen's cryogenic nature causes the materials it touches to become extremely brittle. Handling cryogenics can be difficult and dangerous, so SpaceX stores its liquid oxygen in a liquid oxygen ball. Starship has employed helium throughout its test flight program. Helium is used for tank pressurization, turbopump spin-up, and mass reduction. Helium was also used to prevent ullage volume collapse, which happened in a prior test flight. Ullage volume collapse is the process of stirring the contents of a cryogenic liquid tank to reduce pressure. Starships are nearly capable of flying without helium, but it's a very useful resource for Starship's test flight program. Starship is built out of stainless steel. To create stainless steel, carbon converts iron to hard steel, and then chromium converts hard steel to corrosion-resistant stainless steel. Starship is built out of stainless steel because it is less expensive and more heat-resistant than other potential materials. Stainless steel is inexpensive, as it can be acquired for $3 per kilogram. Steel is 65 times cheaper by weight than the original carbon fiber composites that SpaceX planned to use for Starship. SpaceX developed its own ultra-hard, cold-rolled stainless steel alloy in-house, further reducing costs. Tesla is also using Starship stainless steel alloy in their Cybertruck, making the material more abundant around factories and cooler. Stainless steel is a strong and heat-resistant material. Furthermore, stainless steel strength is boosted by 50% when it comes into contact with cryogenic methane and oxygen. So it gets stronger as we fly higher. At cryogenic temperatures, stainless steel has both a higher strength-to-weight ratio and a higher melting temperature than carbon fiber composites. The 310S stainless steel alloy that SpaceX created stands up to 1450 degrees Kelvin, starts to react with oxygen and corrode at 2000 degrees Kelvin, and melts at 2400 degrees Kelvin.